We'll start with 15, and then if you guys have anything else you want to see, please let me know. So this is on page 59, number 15. 15 has this diagram with it. It says in the figure, line BF is perpendicular to line AE, and the measure of angle BOC is X, and the measure of angle GOH is Y. So let me do my best to draw us a little diagram here so we can talk about some of these. So this is on page 59, guys, if you want to follow along. And then this is C. Okay, and then we have that this angle is X and this angle is Y, and that these are perpendicular. Therefore, they make a right angle. So for number 15, it wanted us to find angle COH, like give it a little expression or a label. So the first thing I would do in something like this is if you're given a diagram, see if there's any extra information you can figure out about that diagram before you start. Like look for angle relationships, right? Where else might you have right angles, things like that. Now, if I'm looking at this picture, there's a lot of intersecting lines, right? And if you have a lot of intersecting lines, does anyone know what special angle relationship you're going to have a lot of? Yeah, vertical angles. These, whenever you have like those X shapes happening, you're going to have vertical angles. And what do we know about vertical angles? They're congruent, which might be helpful because we know some some measurements, right? Like, oh, and I forgot my O here, but if angle BOC is X, then we know angle GOF will also be X because it's vertical to it. If we know angle HOG is Y, then we know COD would also be Y. So some of those things could be helpful. I would always label that first. So this wants to measure, or it wants a label for COH. So COH, that's right here. Well, if you take a look, COH is made up of angle AOH, AOB, and BOC, right? Things I would look for is, okay, well, what do I know about these angles, or where do I maybe have some straight lines, things like that. And if you, do you want to say something, Brennan? Oh yeah, what do you think? Uh-huh. Yeah. Yeah, exactly. You have a straight angle here with angle COG, right? And that's 180 degrees, and that includes everything except Y. So you would do 180 minus Y. Good. Yep. That's exactly what I would do as well. Does that help with that one? Riley, does that help with that one? Yeah, okay. Were we okay on the other ones with this, like HOF and DOE? Brennan? 17, sure. 17 angle DOE. So that is angle DOE. Okay, that one's right here. So, okay, for this one, what you have to do is, since you have a right angle here with angle BOE, right? That would be how many degrees? 90. And it's everything in that 90-degree angle except whatever X is and whatever Y is. So what you would do, and there's more than one good way to write this, the way your textbook writes it is that you would take 90 minus the quantity X plus Y. But it would also be the same if you did 90 minus X minus Y. Either way would be appropriate to write it. Good. Anything else with that one? Brock? That's okay. Oh, okay. Yeah, absolutely. Yeah, we'll add that to the list. So page, no, you're welcome. Page 63 number. Yeah. And I guys, by number yeah, because this one doesn't have a 20. By number 22 and 20, I assume we mean proofs. Anne Marie, by 20, did you mean the proof number 20 on page, I don't know, whatever page that is. On page 64, okay. So yeah, we'll go to that one too. Okay, so these ones, and I'll specify for if someone goes back and looks at this later, this is on page 59. Okay, so then, yeah, the rest, for the number 19 one, I assume that one was a proof too, right? Okay. I think I just assumed this one because someone in fourth block had a question about it. Okay, so we are gonna go to page 63 then. So now we're on page 63. We'll go in order. We'll do 15, then 19, then 20, then 22. So number 15 here, it said copy everything shown and complete the proof of theorem 2.7 for the case where two angles are supplementary to the same angle. It said that angles 1 and 5 are supplementary, 3 and 5 are supplementary. Prove angle 1 is congruent to angle 3. So for this proof, I'm not gonna write down all the columns, but I'm going to write my given and prove. So that way we can kind of look at this diagram. So we were given that angle 1 and angle 5 are supplementary, and that angle 3 and angle 5 are supplementary. We want to prove that angle 1 is congruent to angle 3. Now, the main thing with this one, Brock, is you're basically proving the theorem that says if two angles are supplementary to the same angle, then they're congruent to each other, which we might have done a similar proof in our notes. I'm trying to remember. I think one we did in our notes was maybe similar, but what you're going to do here is if things are supplementary, that means they're going to have to add up to be what? 180. So you're going to have two different sets of angles that add to be 180, right? And if two equations both add to be 180, we're going to set the equations equal to each other, subtract out equivalent values, and end up with what we need to be congruent, okay? So that'll be a very common process that you'll see in some of these proofs. You'll notice that the steps kind of start to repeat themselves. There's only so much variation that can happen. So step 1 was just your given. So you just copy that one down. Angle 1 and 5 are supplementary. Angles 3 and 5 are supplementary. What's always your first reason given? So I guess I'll copy it down so we can see it. So 1, 1. Okay. You ready for a lazy teacher moment? That's my lazy teacher moment of the day. That's given. I would not do that on a test. I'm just doing it right now to save me a second. Okay, so step 2 then. It says that you're taking the angles and adding them up to be 180 degrees, right? So use your context clues. If I'm saying that the measure of angle 1 plus the measure of angle 5 equals 180, and the measure of angle 3 plus the measure of angle 5 equals 180, what lets you say that, right? I was given supplementary angles, therefore I can conclude that they're going to have a sum of 180. Very good. That's the definition of supplementary angles. Good. All right, then the next thing is it then told us for step 3, it then set those equations equal to each other. So it said that, I'm going to move this over so I have a little bit more room here. it said that the measure of angle 1 plus the measure of angle 5 equals the measure of angle 3 plus the measure of angle 5. Now, I would take two different answers here. There's two things that could work. You're taking two equations and setting them equal to each other. What in step 2 makes that reasonable? Why are we allowed to do that? Take a look at step 2, guys. Brennan? It is absolutely because they're both equal to 180. If you have two equations that equal the same thing, that is almost never a coincidence. It wants you to do something with those values. So if both equations equal 180, are you allowed to set them equal to each other then? Absolutely, but what would be an appropriate reason? Substitution would absolutely be appropriate. Does anyone have another option that would maybe be appropriate, Brenna? I would also accept transitive property. Transitive property can be used with both equations and statements of congruency. As long as two things equal the same thing, then they equal each other. So that transitive would also work. They're not always interchangeable, but this is a situation where they are. Like you cannot use the substitution property if it's a statement of congruence. That only works for equations. Okay, good. And then step 4. What does it say for step 4? So now step 4 is something that if you're writing your own proof, I find this step to be a little redundant. Okay, I think I mentioned this to you guys that like if I'm writing a proof, if something already, if it's the exact same number, I don't make you guys do the reflexive property, okay? Your textbook does, so that's totally fine. They have the measure of angle 5 equals the measure of angle 5 by the reflexive property. You are 100% allowed to do that, right? That's fine. That is correct. I don't do it in my proofs. So then for number 5, though, this is another place where your book and I differ. I would do this in one more step. Because the way your book does it, they then take that 5 and what are they going to do with it? They're going to subtract it out, right? It's equivalent on either side. They're going to subtract it out to get the measure of angle 1 equals the measure of angle 3 by the subtraction property. This is where your book and I don't get along as great. Because they're then saying within the same exact step that angle 1 is congruent to angle 2. But is this a congruent sign? No. Can you use the subtraction property if there was a congruent sign? No, it's a property of equality. I don't know why your book does it. It drives me nuts. It's a really good book, except I don't like that one thing. So I would personally, if you're doing your own proof, I want you guys to do your next step would then be to take your equation and convert it into a congruency statement. Because if your angles are equivalent, will they be congruent? Absolutely. And does anyone know what definition lets you do that? It is, yes, definition of congruent angles. Okay. So again, your book combines it. I don't know why, but equal signs and congruent signs, you can interchange them, but not within the same step. Okay, because that's its own definition. Does that help for that one, Brock? Okay. All right, what was the next one we wanted to see? Number 19. Okay. All right, number 19, this is on page 64. Here we are given that angle 2 is congruent to angle 3, and we want to prove that angle 1 is congruent to angle 4, and then we have this little like crisscrossy shape here. that. I actually really like proofs like these. Okay, so we want to prove that angle 1 is congruent to 4. But we're only given that 2 is congruent to 3. So what that means is we're going to have to use some information, likely from our picture, to figure out how we can tie angle 1 to angle 4. All you're given is this one set of congruent angles, that's it, right? So you're going to have to develop your own way. How can I introduce angle 1 into my proof? How can I introduce angle 4 into your proof? Well, if they're not mentioned at all, you're likely going to have to look at your picture and see what additional information you're given. And if you look at your picture, is there an angle relationship happening? Which kind? Vertical angles. We have our X shapes, right? When you have your X shapes, you're going to have your vertical angles. 1 and 2 are vertical, which is going to mean that they're what? Congruent. 3 and 4 are vertical, which is going to mean they are congruent. So technically, won't all my angles be congruent here? And if they're all congruent, can I apply the transitive property and then just state the 2 specific ones that I want? Absolutely. Okay, so first let's put our given. Angle 2 is congruent to angle 3. That is given. And now we need to introduce angle 1 and angle 4 into our proof. It is up to you if you do this in 1 step or 2 steps. But how could I introduce it into my proof? What can I say? Very good. Yeah, the only thing I would say is we take congruent instead. But yes, we're going to say that angle 1 is congruent to angle 2. And we're going to say that angle 3 is congruent to angle 4. And yes, that is the vertical angle theorem. We almost never use the definition of vertical angles in proofs. It just doesn't happen very often. You'll use the vertical angle theorem a lot. Now, that's where your definition sheet is going to come in handy, which you are allowed to use, okay? Make sure you have the updated version. It says updated on the front, so make sure that's the one you have. Now, what if you're taking your test and you're like, oh my God, I can't find my definition sheet. I know it's vertical angles. I don't know what to call it. What do I do? I'm going to get it wrong, and then you have a panic attack. And you email me and go, I don't know what to do. What I would do is I would write an explanation instead. Aren't technically all your definitions and all your theorems and all your postulates, aren't they just statements? They're just names of these statements, right? I've mentioned before, the names of them are arbitrary. You might go to a different book and they might be called something completely different. If you can explain it, if you can give me an if-then statement, that's fine. So if you know if angles are vertical, then they're congruent, say it. That's fine. It means the same thing, okay? So now I have my vertical angles, and guess what, guys? Brennan? Oh, yeah. We're actually done. We're on our last step. Because, now there are ways you could do it with more steps. You could. Well, I'll have you tell me what you did in a second. But if you take a look at your given, aren't angles 2 and 3 congruent? And if angles 2 and 3 are congruent, can we then conclude that 1 and 4 will be congruent as well? Yeah, that's just like the transitive property. Huh? Oh, yeah, that's fine. And you're welcome to take more than 1 step with that if you want. Or some people even like to do it in like baby steps. Like they want to first show that 3 is congruent to 1, and then they want to show that something else is congruent to something else, and that's fine. If you're more descriptive, you can't be wrong, right? So I'm just going to go right to my final step, though, and say angle 1 is congruent to angle 4, and that's the transitive property. And then we're done with that one, actually. You could have used more steps if you wanted. Are there any questions about that one? How are we feeling about this, guys? Okay. And if you were like, I got all these right, then I mean, you know, take this time to work on maybe some of those like proofs online, or like do something that's going to help you review. But I always think that looking at help proofs is helpful. Let me get to another page here. Are we entering? We are. Excellent. Okay. I think what we wanted 20 next. I think someone requested number 20. Okay, so we are on page 64, number 20. We are given that angle 3 is supplementary to angle 1, and we are given that angle 4 is supplementary to angle 2. We want to prove that angle 3 is congruent to angle 4. Okay, and then we had this kind of like two-part diagram here. With angles 3 and 4, and then our intersecting lines with 1 and 2. Okay. All right, so first thing is always your given, right? On your test, please write it, but for today I just wrote it, so I'm going to be lazy for a second here. And this is probably how I'll like do it on your test. Like I'll type out your given and your proof. I'll give you the blank chart, right? And then if you're learning from home that day, you can print it out and write in it and send me upload your picture. Or if you're in class, you'll like have the paper that you can write in, and then I'll collect it. So here's your given. So let's take a look at our picture. Let's plan this out. What are we going to do? We want to prove that angle 3 is congruent to angle 4. And we are given that 1 and 3 are supplementary and 4 and 2 are supplementary. This is very similar to that first proof that we did. I think it was number 15, the one Brock asked for. It's kind of a different picture. If angles are supplementary, what are we going to be able to say about them? They add to be 180. So won't both of these add to be 180? Is it ever a coincidence when two equations equal the same thing in a proof? No. We'll be able to then set those two equations equal to each other, right? Then, what kind of angle relationship do we have here? Vertical angles, and we know vertical angles are always congruent, which means they'll have equal measures, which means will we then be able to subtract them out from our equation and just end up with 3 and 4? Yep. I know I kind of just did that fast, but let's write it down. Let's see what happens here. So, scoot this over so I have more room to write. Okay, so if you are given supplementary angles, what do I want you to state in your proof next? How would you write it? What would you say? Again, I don't have to write them down next week. You do. So what would I write? Come on, guys, be brave. What did we just did it in another one? What would I say if angle 3 is supplementary to angle 1? What would I write in my next step? Brock? Good. And what, since it's an equation, what do my angles need in front of them? What little letter? The M for measure, right? Because we're talking about measurements. So good. We would have the measure of angle 3 plus the measure of angle 1 equals 180. Could I then do the same thing for 4 and 2? Can I do it in the same step? Sure. Can you do it in another step? Sure. Would you maybe need to like add another line at the end? Maybe. Depends on how many lines I take into account. So we can now do the same thing for 4 and angle 2. Oh, my pen turned off. All right, that is the definition of what? Good, definition of supplementary angles. Okay. And this is actually a good example of one that there's more than one correct order to do this in. Like if you wanted to, we're gonna have to introduce our vertical angles at some point. You could have done that first if you wanted. There's nothing that says you can't. But now the next place I'm gonna go is I have two equations that equal the same thing, right? If they equal the same thing, what can I then do with them? Set them equal to each other, good. Yeah, they both equal 180, so I'm gonna set them equal to each other. The measure of angle 3 plus the measure of angle 1 equals the measure of angle 4 plus the measure of angle 2. What would be an appropriate property? Sure, substitution. No. It doesn't want to let me erase it. That's okay. Okay, yeah, substitution sounds good. I would also accept transitive there. All right, but now I want to end up with only angles 3 and 4, right? So I got to now figure out a way to get rid of 1 and 2. Well, look at your diagram. What extra information are we given about 1 and 2? They are what? Yeah. Yep, they are congruent because they are vertical angles. Good. And we specifically want to do congruent because the vertical angle theorem specifically says congruent. So we're going to say that the measure of angle 1, or not the measure, I'm sorry. I just said to use congruent. Oh, good, my eraser's working again. So we are going to say that angle 1 is congruent to angle 2 by the vertical angle theorem. Or you can write a statement, if angles are vertical, then they are congruent. What should I do next? I will need to subtract them, but take a look at our notation. Can we subtract them quite yet? You are right, though. We definitely will need to subtract. I have an issue with my notation, though, before I subtract. Does anyone know what our notation issue is here? It's not a mistake. We just need to do something extra first. Isn't this an equation with an equal sign? Is step 4 an equation? It's a congruency statement, right? Can I turn it into an equation? Absolutely. And then can I subtract them? Absolutely. I have to first say that they're equivalent before I can subtract them out because it's a property of equality. Does that make sense? Okay. So we're going to say that the measure of angle 1 equals the measure of angle 2. That is the definition of congruent angles, right? If the two angles are congruent, then they have equal measures. Now I know these are equivalent and I can apply my subtraction property of equality and I can subtract them out. So the measure of angle 3 equals the measure of angle 4 because I subtracted those. So subtraction property. Make sure you put property on that one. And then step 7, we're almost there. What is the final thing that we need to do? Brock? Make them congruent. And if they have equal measures, are they congruent? Absolutely. So that is allowed. Angle 3 is congruent to angle 4 by what? Definition of congruent angles. Exactly. Good. Anne-Marie, did that help on that one? Okay, you're welcome. All right, I think, well, we got one more. Is it the doozy one? Is it 22? All right. Hold on to your seats, kids. I'll roll up my sleeves. This one's good. All right, 22. What time do I get out of here? Okay. Okay, so we're doing okay on time, actually. That's good. All right, so number 22. We are given that the measure of angle 1 equals the measure of angle 2, and that the measure of angle 3 equals the measure of angle 4. We want to prove that ray YS is perpendicular to line XZ. And we are given this diagram here. Okay. So what makes this one kind of tricky is that I'm trying to prove that I have perpendicular lines, right? Which means I need to make what kind of angle? A right or a 90-degree angle, right? But am I given that anybody's like complementary or anything like that? No, and that's what makes this challenging, okay? So this is actually a perfect problem that I would kind of start to look at backwards. If I need to prove that these are perpendicular, I need to make a 90-degree or a right angle. But I do not know that any of these are complementary. It does not tell me. However, what kind of angle do I have in my picture? Emily? I have a straight angle. And how many degrees are straight angles? 180. Okay. How could I turn a 180 into a 90? It's the only measurement I'm going to have. If I can show, yeah, either that it's bisected, right? Or if somehow I can figure out a way to cut it in half, right? Then I'll have a 90-degree angle. So what we're going to have to do here is show that we have first a straight angle. We're going to have to show that our parts add up to be our straight angle. And then we're going to have to come up with a way to cut that straight angle in half and make a 90-degree angle. It's kind of a tricky one. It's going to involve a lot of angle addition and then like substitution and things like that. And this is a one that you could definitely do in more than one order and it would be fine, or there's even more than one strategy you could take. So let's have our two columns here. Remember, your given always goes first. That would be your step 1 here. Okay. So now step 2. Again, you can approach this in a lot of different orders. The first thing that I'm personally going to do is I'm going to show, I want to start to talk about my numbers, right? I know that I have a straight angle here. That's actually where I'm going to go first. It's not where you have to go first, but I'm going to introduce that angle X, Y, Z is 180 degrees because it's a straight angle. That way I can just go ahead and get that angle started in my proof. And if you guys have a suggestion on where you want to go next or something you did, please let me know. So the measure of angle X, Y, Z is 180 because of the definition of a straight angle. Except I can't spell. Okay. Now the reason I decided to introduce that first is because angle XYZ is where all of our other little angles live, basically, right? It's made up of all those little parts. Now, what I'm going to do is I want to just show that either angle SYX or SYZ is a right angle, either one. It doesn't matter which one you do. But aren't those angles, isn't angle SYZ made up of angles 2 and 4? And isn't angle SYX made up of 1 and 3? And those are the only things we're given information about. So we should probably use those and show that those angles are made up of those smaller parts. So, and again, order here is kind of relative with this one. I guess the next thing I'll do though, before I talk about all my small parts, is show that the measure of angle XYZ is made up of those two larger angles. So I can get those into my proof. So I'm going to say that the measure of angle XYZ equals the measure of angle ZYX, or not ZYX, SYX, plus the measure of angle SYZ. So now I've shown that this angle is 180 degrees and it's made up of these two smaller parts. And then what I'm going to do with that is, can I take those smaller parts and break them up even more with 1 and 3 and 2 and 4? Yeah, so that's what I'm going to do next. So, oh, and I did that, by the way, by the angle addition postulate. Okay. So now for step 4, I'm going to then show that these are made up of even smaller parts. Again, you have another strategy, try it out and let me know. I'm going to say that the measure of angle SYX equals the measure of angle 1 plus the measure of angle 3. And then I'm going to do the same thing with the measure of angle SYZ. That's going to equal the measure of angle 2 plus the measure of angle 4. And I use the angle addition postulate again there. What was the point of me doing that? Does anyone know? Why did I take the time to now show that these are made up of all my smaller parts here? Emily? Yeah, they were in the given. They're the only things we know information about, right? So we should mention them. And why it's important to mention them is, aren't they going to be congruent? So now let's start to think about this. If these are congruent, if like 1 is congruent to 2, 3 is congruent to 4, will I be able to rewrite these so they kind of look the same? That's what you did. Good. That's exactly what you should do, because if they look the same, then you'll be adding the same thing to itself, right? And isn't adding the same thing to itself the same thing as multiplying something by 2? And what's the opposite of multiplying by 2? Dividing by 2. And then could we maybe get 90 degrees? Yeah. Okay. So that's what I'm going to do next. For step 5, I'm going to, and it doesn't matter which one you go with, right? Pick whichever one you like. You could substitute 1 in for 2 or vice versa. But I'm going to rewrite, just because it's on the bottom, I'm going to rewrite the measure of angle SYZ as the measure of angle 1 plus the measure of angle 3. And the reason I could do that, remember in your given, we were told that angles 1 and 2 were equivalent and that angles 3 and 4 were equivalent. So I just replaced those values. So that was substitution. Okay, then step 6. Now again, what was the point of doing this? Well, if you look at angle XYZ, isn't it made up of SYX and SYZ? You tired back there, bro? I know, this one's intense. So what I'm going to do here is I'm going to now replace this. Aren't these equivalent? SYX and SYZ? Aren't they equivalent? So can I replace one for the other? Absolutely. So I'm going to say that the measure of angle XYZ equals the measure of angle S. Yeah, or wait, I think I actually have to do something else first. Because right now, I think I skipped a step. Mm-hmm. Oh, yeah. Oh, so you set like, I see. Yeah, so, okay, yeah, no, you're right. So yeah, what I actually have to do is, I mixed myself up here. So yeah, now since these are equivalent, then what I actually have to do next is say that these are equivalent. Yeah. Yeah, and that's okay. Yeah, if you want to use the numbers instead, or you want to use the like bigger measurements, that's fine. I'm gonna say that the measure, yeah, I can't substitute that in yet. I have to first say that the measure of angle SYX equals the measure of angle SYZ. That was a step I missed. And you can use the numbers instead. Is that what you said you did, Riley? Oh yeah, that's fine too. Yeah, either way. Either way, it would still be substitution. Again, this is like the world's biggest substitution proof, basically. Okay, now I know these are equivalent, right? So now I can replace one in for the other. So I'm going to say the measure of angle X, Y, Z equals, and you can pick either one. I'm going to say the measure of angle SYX plus the measure of angle SYX, because those were equivalent, so I can replace. So again, for the 100th time, substitution. We're almost there, guys. What kind? Like for a laptop? Yeah, I do. If you go behind my desk, there's one above my Chromebook there, like on the shelf. All right, so now what was the point of this? Well, isn't adding something to itself the same thing as multiplying by 2? Yeah, so I'm actually going to convert that. And you can convert that in the same step or in separate steps. It's up to you. I'm going to say that the measure of angle XYZ equals 2 times the measure of angle SYX. I'm just going to do that all in the same step because that's also technically substitution. Now, why do that? Well, doesn't that equal 180? Yep. So I'm going to say that 2 times the measure of angle SYX equals 180. That's again substitution. And now can I divide? Yes. And I'm going to say that the measure of angle SYX equals 90. That's the division property. Do I finally have a right angle? Yes. 100 years later, we finally have a right angle. So now can I finally say that those two things are perpendicular? Yes. I don't want to go to another page with it. So, oh, good, I have some room. Step 10. Whew. If these are 90 degrees, then I'm finally at my proof. Ray YS is perpendicular to line XZ. And that is the definition of perpendicular lines. That was a beast. How do we feel about it? I skipped step 4. Would that matter when you are grading? Oh, for number 20, Libby? Let me look. Yes, that would matter, Libby, because you have to introduce the vertical angles first before you can do anything else with them. So you have to introduce them by saying the vertical angle theorem first. Okay. Whew. Anything else? Mm-hmm. Oh yeah, and then like use the definition of an angle bisector. That would be okay too. Yeah, that would. No, that could also work. So yeah, once you say that you have that like these angles are equal, wherever we did that, like step 6 here. Yeah. Once we said that those were equal, you could use your You could say you had a bisector. Yes, and that would be definition of an angle bisector. And then if you have the bisector, then you would know that they were, cut in half. Yeah, I would have to see what your reasons were, but it should work. Yeah.